Where are the other students? Only 12 participants. Good morning, everyone. A very good morning to all of you. Um, New semester started, 6 semesters. Still everyone is sleeping. Hmm? Just now, I took class of mechanical second year, fourth sem. 40 students joined. 40. I mean, what is their strength? They joined. And what about you? EC students sleeping? No response. Okay. A very warm welcome to you all in your new semester, sixth semester. So I will be taking your professional elective subject, that is electronics and instrumentation. Okay. So first, let me share with you the QR code. Okay. Give the attendance, and then we will start. But attendance visible to you all, and see whether you are able to give it or not. And please do check your LMS portal that you all are enrolled in this particular subject or not. It's written sixth semester EMI. Okay. Do check whether you all are enrolled or not in that particular subject. That is important. Attendance हो रहा है ना?
Yes, ma'am.
Yes, ma'am.
ओके. और सब अपने एलएमएस पोर्टल में काइंडली चेक कर लेना कि तुम्हारा ये सब्जेक्ट शो कर रहा है कि नहीं, बिकॉज आफ्टरवर्ड्स डोंट टेल मी. Okay, so I think you have all given your QR code attendance. Let me share with you now the syllabus you have. Syllabus is visible. This syllabus I will upload in LMS portal. Don't worry. Okay, so this is the name of your subject, that is EC605N, and this is the electronics measurement and instrumentation. Okay, name of the subject. And these are the topics we will cover. All the modules. Okay, module 1, 2, 3, 4, 5. We have 5 modules. So in each module, there are big topics, as you can see. For in module 1, you have measurement, error, bridge, measurements. Module 2, you have some measuring basic parameters, CRO. CRO, you all are much aware of CRO. Okay. And if my voice breaks, then kindly let me know. मुझे पता नहीं चलता है. Okay, you people will tell me. कि मैम your voice is breaking. Chat box में मत लिखना because I don't check chat box much. And only 17 students. Where are others? Huh? Come on, new semester started. पढ़ने में तो अच्छा लगना चाहिए ना. Then how you will do? क्या करते हो पूरा दिन घर में बैठे बैठे? हाँ? मनोरमा, tell me. पूरा दिन पढ़ाई नहीं करोगे तो क्या करोगे? Okay. So in module 2, you have some basic parameter measuring and then CRO. And 3, you have instrument for generation, then analysis of waveform, some related to your microwave, some spectrum analyzer, all those things. Then comes in module 4, transducer and signal converters, some related to digital electronics and basics of this sensor and transducer. And last module, you have isolation techniques, that is Hall effect, all those things. And last is data acquisition and conversion, DAS, some sample health code operation. These are some of the things you already have learned in your analog electronics or analog communication part. And here are some parts of PLC, data acquisition techniques, some are there. Okay, so I will upload this syllabus in your LMS portal. So make sure you all are able to see this particular subject in your LMS portal. That means if you are enrolled, only you will be able to see the subject. And if you're not enrolled, you won't be. So if anybody is there who are not enrolled, please do let me know. Okay, this is the thing. Okay, so we can start with our session. We should start now. Respond. We shall start.
Yes, ma'am.
Okay, thank you.
Yes, ma'am.
Yes, I want the response. Okay, this is chapter 1, measurement and error. Don't worry, I will provide you the notes. Don't worry about that. Chapter 1 is all about measurement and error. Now, those who are from ICSE CBSE board, if you have nicely learned your class 11 physics book, then you must have learned about the error. Error part is very prominent in chapter 2 of physics of class 11 CBSE board, as per my knowledge. So you have a basic idea of the errors that are occurring in basic during measurement in basic instruments. Okay, so let us discuss something this chapter. First of all, summary. Instrument. You know what is instrument? You are using instrument in your everyday life. Okay, well, see, for any measurement purpose, for anything to deal with, we need instrument. Even to measure a small thing also, even to measure how much sugar we are giving in a cup of tea, we need to measure. Okay, so for everything we need a device, that is for instrument, that actually gives the original value of a quantity. Okay, or the present value, you can say it's more accurate, present value of the quantity. That's how much, what is the present quantity of that particular, or present value of that particular quantity. So that is instrument. Then comes measurement. Measurement is what? It's a method or process, you can say, of comparing an unknown quantity with an accepted standard quantity. So always remember one thing, whatever we are measuring, whatever we are measuring, it always have a standard quantity. Okay, and I mean, any particular quantity is having a standard value. Okay, every time. And what we will measure, that is the unknown quantity. So what we try to do, we try to compare the unknown quantity with the standard one, so that we can understand that the error, or what is the difference in measurement with the standard and the unknown quantity. Okay, what is standard? An instrument or device having a recognized permanent stable value that is used as reference. Oh, this happens actually in physics also, that we always refer to standard value. We take a standard thing, and then with respect to that standard value, we try to do the measurement. Okay, so it becomes easier. So usse kya hota hai, we have a clear cut idea, you know, the measurement of this quantity can be like this. It may deviate from the standard value, plus minus 10, it can deviate. So if you know the standard value of any particular instrument or device, then it will be easier for you to use it as a reference. Okay, understood this much portion? So next, next I'm moving to some of the errors. Now, during measurement, these are the very common errors you may face while if you have done your physics lab properly in class 11, then you are much more familiar with these errors. One is gross error, systematic error, random error, absolute error, relative error. Some problems are also there in physics of class 11 related to this error part. Okay, so come to first of all error. What is error? every instrument, each and every instrument gives error. Okay, because during measurement, see, first of all, we don't do measurement in any vacuum space. There is always a medium called air. Okay, and because of this kind of medium, there actually comes some error part also when we try to measure a value. And error means what we are measuring, the difference of the measured value from the true value. Okay, so difference or deviation from the true value of the measurable quantity, that is the deviation, means that is the error. That means what? Suppose X is an object, okay, and its true value is something which is already been given in a book. Suppose its true value is 1, okay, but after my measurement, I saw that in that X object, the value which I am getting, the measured value, that is 1.2, okay. So 0.2 is the error. That means the difference or deviation from the true value of the measurable quantity, that is called the error. I hope this much thing is clear to you all. Error. Now, important is this formula. Formula of error. In many times questions come, find the percentage of error. So error हम कैसे निकालते हैं? True value minus measured value divided by the true value, multiply by 100%. Okay, and if you want to get accurate value, then you need to follow this particular formula. See here, one is the error value. This is the error value, error percentage actually. True value minus measured value, multiply by 100% divided by true value. Okay, it is important. And the second one is the, if you try to find out the accurate percentage, that is 100% minus percentage of error. So these are required when you will solve any problems. In that case, you will require these formulas. Okay. Wait for a second. Okay. Now, next here a circuit has been given. See, refer a circuit. They are referring a circuit below here. Calculate the error percentage and the accurate percentage if meter ampere shows the value of, this ampere spelling is wrong. Okay, this will be AM ampere, PERE. Okay, so don't get confused. So the meter ampere shows a value of 6 milliampere. So I hope this figure is visible to you all. So what is here? A supply.
Yes, ma'am.
Yes, we know. A supply is given of 15 volt. Okay. And here loads are connected. One is 1 kilo ohm, another is 2 kilo ohm with a milliampere. Okay. Now you have to find out the calculate the error percentage and the calculate the accurate percentage. Now see, if you apply in this particular problem, see, if you can see this problem, then apne copy mein thoda is problem ko draw the figure. Then what you will do at your home, you will use this error percentage and accurate percentage, and you will tell me the answer in next class. In next class, you will solve this problem using these two formulas, okay? And you will tell me the answer in the next class. So if you have copy with you, then do this figure fast. Take down this figure. Supply of 15 volt, and then there are two loads connected, 1 kilo ohm, 2 kilo ohm. Okay. So done. You have taken the diagram.
Yes, ma'am.
Okay. Then I'm moving on to my next slide. Okay. Okay. Now, errors are generally categorized into 3 major headings. As I told you, gross error, systematic error, and random error. So these 3 errors are very, very important in EMI. Okay. We mainly whatever calculations we do, we try to mainly evaluate these 3 errors. So let us see what these errors in my slide is given. Acha. Now, first of all, it comes gross error. The word gross error you can see here. There are three main points in gross error. Once you just go through this slide, you can see that generally the fault of the person using the instrument, such as incorrect reading, incorrect recording, incorrect use, and they can be avoided only by taking care in using reading on instrument. So it's very clear that gross error is only possible because of any fault that is done by a person using that instrument. See, instrument, there are many instruments in our lab, but sometimes what happens, we all don't know that sometimes this may happen that we all don't know how to use an instrument, or we are using, but it happens to have some fault in that instrument because of the use, but we are unaware of that. Okay, so due to that, what happened while taking reading, if the calibration is not proper, if we have not placed the the parts properly anywhere, we will get incorrect reading. We will get incorrect recording, okay, because only of the incorrect use. So unless and until that particular company people come, that instrument from where we have taken, we cannot find the fault. Okay, but yes, we can see some tentative readings are coming that may be not equal to the reading which is actually it should come. So in that case, you can understand that some gross error is happening in that particular instrument. Okay, but yes, this can be avoided if we take care of the instrument and the readings. That means it's very important that from where you buy the instrument, you call those person for the demo, and so that if any fault occur, that particular experienced person will help you out, that no, this is the problem you are doing with the instrument. Otherwise, it's not possible for everyone to know every operation of the instrument. Okay, so this thing is very common, and this is called as gross error. Okay, now next we will move on to systematic error. This is a very common error actually happen. Systematic error. Systematic error can be divided into two different categories. One is instrumental error, second is environmental error. Okay, so systematic error, why it is very common? Because whenever we are measuring anything, because of their electrical or mechanical structure, some errors come. How? See, here example has been given, stretching of the spring. This is one type of example, but in any laboratory, if you are present, okay, some things happen because of this structure, that it happens to give some kind of error. Here a simple example has been given, stretching the spring. Okay, sometimes what happens, we don't know up to how much length we need to stretch the string. If someone exceed that particular length, then the reading which will come, that will come with the including the instrumental error. Okay, now see, instrumental error can be avoided. How? Selecting a suitable instrument for the particular measurement application and calibrating the instrument against the standard. See, this calibration is very important. Whenever we are using this hardware instrument, mainly in laboratory, suppose basic electrical, basic electronics, or you can say machine lab, or this kind of big labs actually, where we don't use software, we use only hardware instruments, their calibration is very important. Because unless and until you calibrate the instrument against the standard value, there may sometimes occur some instrumental error. Okay, and lastly comes environmental error. Now this is very common, and this is very natural also, because external conditions, they may affect the measuring device. Okay, that in which area that instrument is installed. Suppose the weather is very rainy, and the instrument which is in which room it is installed, the room has got some damp. Okay, due to humidity or continuous raining for a long time, then that may affect the instrument. Okay, so in that case, if any error occurred due to change in temperature, humidity, air pressure, then we can say that is actually the environmental error. So under systematic error, two errors come, that is instrumental error and environmental error. Okay, so I think this much is clear to you all. Next, we can move on to random error. So I told you that we have three important errors: gross error, systematic error, random error. These errors are due to unknown causes and occur even when all systematic errors have been counted for. That is why we have given the term random. Means it may, I mean, we even don't know. Some errors are very certain that we know that, yeah, this instrument can give this kind of error. But the errors which are very uncertain, and even after handling the instrument with lot of care and considering all the systematic errors, then also some errors arise, and that you can call as uncertain or unknown errors or causes. So that are called random. So this variation cannot be corrected by any method of calibration or other known method of control. And they may be avoided by increasing number of reading, using statistical means to obtain the best approximation of the true table of the quantity under measurement. So according to them, random errors are something. See, sometimes what happened, an instrument, you know, this instrument is about to give this particular value y, okay? But while taking reading, you know, all the errors, according to you, there is no gross error, there is no systematic error. I mean, you have taken accounted all for the errors, but still you are not getting a particular value which you want, okay? So at that time, you have to think that some random errors are coming. So what you will do, you will increase the intensity of taking reading, okay? Jitna reading hum lenge, I mean, if there you are supposed to take 5 readings, you will take 10 to 15 readings. Then you can take the average. Then only it's helpful that you can reduce the random errors. Okay, otherwise there is no other method to control it. And definitely, if you are taking reading of any instrument, you must be having a manual. Okay, then you can actually match it with the best approximation reading table. This is the value can about to come, but I'm getting this much. So you can understand at what level the errors are coming. Okay. So this is all about gross error, random error, systematic error. So up to this, any problem, any issue, tell me. Up to this random errors, if you have any query, ask me. Any query?
Ma'am,
Bolo. Yes, tell me.
how can we know that there was a random error occurs?
Random error occurs. See, in every experiment, the teachers or the assistants which help you out for doing the experiments, उनको पता होता है कि इस particular experiment में reading कितना आ सकता है, ठीक है? अगर हम particular, if we give this much of voltage and this much of current will pass through it, then the output that we will get, it should be, उनका एक range होता है, ठीक है? वो जो मैनुअल भी होता है उस पर्टिकुलर इंस्ट्रूमेंट का, वहां पे भी गिवन होता है कि हाँ, द आउटपुट वैल्यू विल बी इन दिस रेंज. इफ that particular experiment, Prasanjit, kindly mute yourself. Some voices are coming. Yeah. मान लो उसी पर्टिकुलर इंस्ट्रूमेंट पे अगर हम एक्सपेरिमेंट करते हैं एंड वी कैन चेक इट आउट ना कि उस रेंज में हमारा वैल्यू आर कमिंग और नॉट. If we see that our value is not coming within that range and it may be lower that range or maybe exceeding that range, then we can understand it may be random errors. Okay. Dekho, whenever we do any experiment in our lab, we have an idea that this instrument should have the output value of this range. Any experiment, okay? We don't do some arbitrary calculations. We don't do approximate calculations. We know what is the measure, what is the true value and what can be the measured value. Then only we take readings. So if we see that after taking, mute yourself. So if we see that after taking 4, 5, 6 readings, it's not coming under range. So what you will do? You will take at least 10 to 15 readings. Then ultimately, some near about values will come for sure. Okay. So this kind of errors are not controllable. Um, though systematic errors and cross errors it are controllable, but random errors you have to do by hidden trial method every time if it's not giving you the correct file. Okay. So by understanding that what is the range of output it can give, you will be able to know कि हाँ मेरा instrument ये range ये this should be the value of my instrument reading, but it's giving this much. तो वहीं से पता चल जाएगा कि random errors आ रहा है instrument में. हाँ? That is the thing. Okay, Rajkumar, I hope I could make you understand.
Yes, ma'am.
Okay, thank you so much. Then we will move on to the next topic, that is absolute error and relative error. This is another topic. I think those who are CBSE students, you must be have learned this much good clearly in physics of class 11. So let us see here. If the resistor is known to have a resistance of 500 ohm with a possible error of plus minus 50, then plus minus 50 is an absolute error. So see here, according to them, resistance to hai 500 ohm, but they are telling that maybe it has a possible error of plus minus 50. So this plus minus 50 is considered as absolute error. Okay. Relative error is what? Is a percentage or as a fraction of total resistance. So your example has been given to make you understand what is relative error. Suppose 20 volt is there, and suppose there is a measured voltage of 20 volt with plus minus 0.1%, then this is the relative error. Or I'll show you one thing that wait for a second. There is a formula to find out relative error. Wait. Let me stop the share and let me tell you that what is the formula. Chapter. Wait for a second. No. Okay, I'll tell you in the next class. Right now, I'm not finding that. Wait. No, I got it. And let me tell you. Yeah, the relative error, how we actually find out relative error part. Yeah. Let me share with you. Okay, so relative calculation, I will tell you in the next class. Right now, I'm not getting that, which I want to show you. I'm not getting it. So this is, you see here, the measured values are given in two different errors they are showing, right? One CV 20 volt, they are showing plus minus 0.1%, and they are referring this 0.1% as relative error. Okay. Secondly, same measured value 20 volt plus minus, this is 0.02 volt, and this they are comparing, or this they are saying as absolute error. So how you will understand which one is absolute error and which is relative error? This is one question. So see, relative error is always comes in percentage, okay, or you can say as a fraction of the measured value. So wherever if you see any kind of error in percentage, you can refer that as relative error. So this is one tip to understand which is relative error. So percentage is usually employed to express errors in resistance and other electrical quantities. Now here in absolute error, they have given the example with the help of a resistance, but here another example they are showing with the help of a volt. So one thing you understand, for absolute error, whatever be the measured value in resistance or voltage, anything, जो error आएगा, whatever be the error, that will be always in that same unit. Okay, मतलब अगर मान लो I have a error of 30 volt, so say example, then I will get an error of some 0.03 volt. Okay, that will be always in terms of unit that is given in the measured value. But in case of relative error, it will be always give you in form of percentage. Okay, so this is the way how you can identify what is absolute error and what is relative error. Okay, or which one if you are asked to identify. Now let us see here this one thing which I actually wanted, error in measurement, how to find out the absolute error. Now, absolute error may be defined as the difference between the expected value of the variable and the measured value. See, whenever, whatever variable we are considering to find out the absolute error, keep in your mind, we need two values. One is expected value, one is measured value. Measured value we already know, okay, because I'm not the first person to measure that particular variable. Someone before me have already measured, okay, and I may get near about, not approximate that particular number, but near about the value, that is the expected value. It may be 0.0001 difference also, but there will be a difference. Okay, so absolute error is equal to the expected value, that is yn, minus the measured value. So this thing is very, very important, because if you're asked to find out the absolute value of any variable, then you have to use this particular formula. Okay. Next is there is an example. So I want to show you this kind of example actually. So see, an example has been given. The expected value of the voltage across a resistor is 5.0 volt. Okay. However, the measurement yields a value of 4.9 volt. That is what I wanted to tell you, that measured value था 4.9. Okay. But जो expected value आया है वो है 5.0 volt. Then you have to calculate the absolute error, that is E. Okay, then you have to calculate the percentage error and you have to calculate the percentage accuracy. So let us see how they have proceeded in this problem. Oh, the problem is not done. Very nice. So this problem you will do and tell me the answer in the next class. So take down this problem. Then take down this problem. You will do, because I told you the formula of absolute error. You know the formula of percentage error. You know the formula of percentage accuracy. Okay. So you can easily find it out. In my next class, you will tell me the answer. Take down this question. Take down this question.
Ma'am, can you please share the absolute error page?
Whatever.
Absolute error page, ma'am.
Okay, absolute error. Absolute error is all about the difference between the expected value minus the measured value. Okay, that is absolute error. So this is the formula you will use for absolute error. That is E equals to expected value minus measured value. So if you know, if in the question the two things are provided, that is the expected value and the measured value, then you can easily find out the absolute error. And the question now, right now I given you, it's already mentioned what is the expected value and what is the measured value. So absolute error, so just now you can tell me the value about the absolute error. I can see the absolute error is 1.9. Sorry, not 1.9. To the difference between 5 and 4.9. You mainly have to find out the error, percentage error, okay, and the percentage accuracy. That is more important. So I can see the absolute error here is 0.1. You got the absolute error 0.1. so absolute error तो हो गया, और left is percentage error and percent accuracy. One more thing I told you na, the percentage error, yeah, this is the formulas you have to use for percentage error and percentage accuracy. See, these are the two formula. If you have your copy in front of you right now, then please write it over there. Percentage error is equal to true value minus measured value upon true value into 100%, and percentage accuracy is 100% minus percentage error. So if you apply this formula, then you can easily tell me the answer. So next class, I will ask you the answers of these three. Okay. So you all have taken down the problem. You all have
Yes,
taken.
ma'am.
Okay. Okay, Acha. One more thing, let it keep this up to this today. In my next class, I will continue after this problem. Once again, I'm sharing the QR code with you. So kindly, who has left out, give the attendance. And up to this much, I hope you have no query. And if you have, tell me. So today we have mainly learned about the errors, gross error, systematic error, and random errors. Okay. And we have learned absolute error, then relative error, then percentage error, and percentage accuracy. Okay. And I told you to solve a problem. So give your QR code, and thank you for attending my class today. So I think tomorrow again I have class. No, tomorrow I don't have class with you. I again have class on Thursday. So we will meet on Thursday. Tell your other friends to join. Okay, thank you so much. You all can leave the meeting.
Thank you, ma'am.
Thank you.